friends, this is the preview video for Lesson 8.5, Volume of Prisms and Cylinders. This whole unit is dealing with area and solids. Welcome to the very last stretch, which is solids. Before we do that, let's go ahead and review what we've talked about in previous classes dealing with area and probability. Make sure you get a parent, guardian, or teacher sign-off. And don't forget the date, location, and time. Here's a review problem. It says, find the area of the shaded region. Find the percent probability that a point will be in the shaded region compared to the entire circle. Let's highlight keywords. Our ultimate goal is to find the area, then find the probability that a point will be in the shaded region versus the entire circle. Now we draw a label list. We want to find the area of the shaded region. So as you account for stuff, you write it down and cross it out. So area of the shaded region. So area shaded, that's one thing we need to find. Question mark, cross it out. And you want to find the percent probability of the shaded over the circle area. So we take a look here. We have two things to find. I'm going to do this one with you. So step one is we have to identify the shapes that we see here. We see a circle and we see a square. Let's write the area equations for both, since area is what we're working with. Area of a circle now a square is both a rectangle and a rhombus. Make sure you are familiar with both equations for a square. To find the area of a square, we can do like a rectangle, one side length times the other, and a square, it's just side squared. Or like a rhombus, because there's a right angle on the inside, we can do diagonal times diagonal over 2. Make sure you're familiar with both when it comes to a square. So let's look at what's the best. We have that 16 there, and that is half of a diagonal. So we're going to use this equation for the square. So our area of our circle, to find the shaded, it's going to be circle minus square. And our circle is going to be pi, we trace our radius, 16 squared, minus this square, we trace it diagonal, which is not 16, it's 32, times diagonal. Okay, to find the area of the shaded region, you need to get that down to a decimal. So it's 16 squared times the pi key, 804.25. Minus, that's 2 goes into 32 16 times. We have 512. Now to get the shaded, we subtract a circle from the square. We get 292.25. That's the shaded region. And you always want to label everything as you do this. So the shaded region was 292.25. We want to find the percent probability that's in the shaded compared to the whole circle. So we're going to divide by the whole circle, 804.25. We're Round it to the nearest whole percent, which in this case is 36%. Now at the top margin, I'd like you to write, since we did this one together and you weren't on your own, I'd like you to write what were the 3 steps to solving this problem. I'll be looking for that when I do the sign-offs. So I'd like you to pause the video, take about 1 minute, and write down what were the 3 main steps to solving this problem. Pause the video, then restart. Okay, welcome back. Now we're going to move from area to, finally, we're getting into 3D shapes, which is solids. And by the time you're done today, you're going to know these terms, something called a base and a face, a prism, a cylinder, a right prism, and an oblique prism. So there's 2 main solids are 3D shapes. And here's some examples of solids that you're already familiar with. And that is a rectangular prism, a sphere, a cone, a cylinder, a pyramid, and cube. Now solids we're going to break down into 2 families. We're going to have the prism and cylinder family, and then the pyramid and cone family. When you start by drawing these, you start by drawing a base, and then you connect the faces. So watch carefully. You artsy students, you're going to have an edge here. The rest of us non-artsy people, you will get better at drawing these as you do it. So we're going to draw ourselves a square-based prism. So this is a square. Put your hatch marks in there. Now we're going to drop down the sides. Now the edges that you can't see, if this was actually solid, you're going to dot. This back edge you dot and dot. And there you have a square-based prism. Let's try a triangular prism. So a triangular prism, we have a triangle. And you're going to drop that straight down. And then we're going to mirror what this looks like down below. But because it's an edge, we technically can't see if it's solid. You dot it. And we're going to dot that back spine because technically we can't see it. And that's a triangular prism. This is a pentagonal prism, a regular pentagonal prism. We're going to drop this down. Connect those edges. This back edge, we can't see it, so you dot it. And dot that back spine. That is a pentagonal prism. So definition of a prism is basically 2 bases connected by rectangular faces. 2 bases connected by rectangular faces. A prism is 2 bases connected by rectangular faces. Now, it doesn't seem like when you're dealing with a cylinder that you're going to have rectangular faces. But in a moment, you're going to see all a cylinder is a circle, and it has one single rectangular face, like a label on a Campbell's soup can. So technically, it does have a rectangle. It's just wrapped all the way around. So technically, that's one rectangle wrapped all the way around. That is the prism and cylinder family. They're all related because they have 2 bases connected by rectangular faces. 2 bases connected by rectangular faces. As versus the pyramid and the cone family, the pyramid and cone family has 1 base. with triangles connecting to single what's called a vertex. So we're going to start by drawing the vertex for all of these. That's a vertex. It's the point where the triangular faces connect. That's called a vertex. So here's a square-based pyramid. We're going to connect this corner, and that's all visual. So this back one is not visual. Technically, that back edge and this edge is also not visible. So you dot it. This is a triangular pyramid. Not all pyramids have a square base. Please keep that in mind. Solid, dot, dot. Then we have a pentagonal pyramid. You connect all the corners. That back spine's not going to be visible, so we dot it. That's a pentagonal pyramid. And a cone, it's solid. You dot the back because technically you can't see it. And then you have your edges. So again, let me clarify the difference. In prisms, you're going to have two bases. You have colors connected by square rectangular faces. Did you see the rectangles? Technically, this is one giant rectangle there. In pyramids and cones, you have one base connected by triangles of some sort. So for this lesson, we're going to stay focused on this first family, this prism and cylinder family. Now, the main thing you need to understand when we deal with the two bases have three qualities in prisms and cylinders. It's very important you memorize these. The two bases, those two bases are congruent shaped. So they're congruent. Those two bases are parallel. And they're connected by rectangles. They're congruent, they're parallel, and they're connected by rectangles. CPR. Congruent, parallel, connected by rectangles. CPR. Congruent, parallel, connected by rectangles. That is the definition of the two bases of a prism. Say that out loud. CPR. Congruent, parallel, rectangles. Bases do not mean bottoms. It's very important that you understand that bases are not always the bottoms. Write the word bottom and cross it out. Bases and bottom are not equivalent. Bases. In a prism and a cylinder, the two bases are congruent, parallel shapes, and are connected by rectangles. For example, this is a rectangular prism. You have two congruent parallel shapes which are connected by rectangles. And those shapes are the two triangles. The two triangles, they're parallel. First off, they're exactly congruent. Second, they're exactly parallel to each other. You will see they're exactly parallel. And they're connected by nothing but rectangles. They're connected by this bottom rectangle, this back rectangle, and then this front rectangle. So your bases are these two shapes. They're congruent, they're parallel, and they're connected by rectangles. Let's recap that. There are qualities. They are congruent and parallel, and they're connected by rectangles. Now, keeping that in mind, in each of these shapes, there are only two bases that have all three qualities. I'm going to set the timer for a minute. I want you to go through, and I prefer you to use a colored pen, pencil, or a highlighter. And I would like you to find the bases here. Okay? Ready? Actually, just shade, pause, shade, restart. Pause the video, shade, restart. Welcome back. So taking a look, the bases. Remember CPR, they're congruent, they're parallel, they're connected by rectangles. The bases are going to be, ready? There's one base and another base. They're congruent, they're parallel, they're connected by rectangles. Your bases here are these two triangles. They're congruent, they're parallel, they're connected by rectangles. The bases here are the two circles. The bases here are the two congruent, parallel, regular pentagons. Careful here. Many students, they highlight this bottom as a base, but that is not the base. Base does not mean bottom. Base here, again, means congruent, parallel, connected by rectangles. So your bases are actually these two trapezoids. And here, your bases turn sideways, and they are the two circles. Now, when I talk about the word base, I'm always going to be talking about the area of the bases. So the word base and area are actually equivalent. So in all the equations you're going to learn, when you see the base, which is always going to be a capital B in all the equations, that capital B stands for area of the base. So when we work with this, the three qualities of the bases, once again, they are two exactly congruent shapes. They are parallel, and they're connected by rectangles, B, P, R. So whenever you see B, capital B in equation, it must be capital, it means area of, which means if the base shape changes, the area changes. So we're going to go recap what are the area equations you've recently learned. Ready? For a regular pentagon or any regular polygon, you guys learned that that base is going to be perimeter times apothem over 2, pa over 2. So when you work with a regular polygon base, you're using pa over 2. For a trapezoid, that base area, now watch very carefully, is going to be base plus base times the height, right angle, over 2. Now notice I'm using lowercase b. Lowercase b means the length of a segment, whereas uppercase B always means area. So for a trapezoid base, it's base segment averaged with the other base segment over 2 times the height. If our base area is a square or a rectangle, the area is simply, if it's a square, of course, it's side square. If this was rectangular, you would write length times width. The base area of a circle of course, is pi r squared. And the base area of a right triangle, if you were to have a right triangle base, is going to be leg times leg over 2, if it was a right triangle. So really important. All of these are going to be represented by a capital letter B. So your B will change depending on the shape. And we're going to do several examples together so that you're not intimidated by this. So let's start with the simplest shape of this family, prisms and cylinders, which are cylinders. And remember, the bases are congruent, parallel, and connected by a rectangle. So if you have a can, this is really good if you do this yourself, but if you put your hand here, the top and the bottom, those would be the bases. But if you turn the can sideways, it doesn't change the bases. The bases are still the 2 circles, even if they're sideways. So let me reiterate once again, base does not mean bottom. Base means it's the 2 congruent parallel shapes that are connected by rectangles, or in a cylinder's case, technically it's 1 rectangle wrapped around. So here, now we need to cover that. Those are the bases, so darken them or shade them. Height is always the distance between the bases. It's really important you understand that, and it's also perpendicular to the base. So if you draw that, it makes a right angle with the bases. Height is always the distance between the bases. So height is not vertical. Height is the distance between the bases. So that's height this way, and then this would be height going that way. If you change the orientation of the bases, it changes the orientation of the height. So height is always the distance between the 2 bases. It does not mean vertical. Now, the concept of volume as a prism is really, really simple here. When you have a prism, you start with the base, and the base is just a bottom. So, and you remember base means area, so trace this and shade it. There's a base. Find its volume. All you do, if you start with the base, there's the area of the base. The only thing that changes for volume is that you times by the height. Do you see that? You start with the area of the base and you times by the height, and that's going to be volume. Area of the base times the height. Once again, area of the base times the height. We come over here, so the volume of any prism or cylinder is simply the area of the base times the height. Remember, height is distance between the bases. It doesn't mean vertical. Okay, we're going to do several examples together. Keep your calculator handy. So in this shape, I'm going to pause 10 seconds. I like you to shade what you think the 2 bases are. Let me see if you can't spot those. Okay, you should have shaded this. We shade the base. These are your two bases. They are right triangles. So step one, we shade the base, and then I'd like you to pull it out so you know what it looks like. That's your base. Now, we're going to find the area of the base. So this base area, it's a right triangle, and it is leg times leg over 2. So we're finding the area of that base. You only need one. So it's going to be 7 times 24 over 2. 2 goes into 24 12 times. 7 times 12 is 84. And that's going to be units squared. Now to find the volume of this prism, it is simply going to be the area of the base times the height. Notice I used a capital B there. Capital B means area of. So to find the volume, we take the area of the base. So I'm going to circle 84, put it right there. 84 times the height. Height is distance between the bases. So our height here is not 7. The distance between the bases is 28. So it's base, area of the base, times the height. It's 2,352. You check units, there's no units. So we just write units and volume. Volume is 3D. We're dealing with volume, it's three-dimensional. So now we're using units cubed. Congratulations, you just did your first volume equation. The 5 steps you're going to follow, technically it's only 4, but you shade the base, you shade, and you find the area of the base. You write your volume equation, circle, plug, chug. Shade the base, area the base. Equations, circle, plug, chug. Shade the base, area the base. Equations, circle, plug, chug. Shade the base, shade the base, find the base. Equations, circle, plug, chug. Those are your steps that you're using here. Let's try another one. Step number 1, we shade the bases. And there's always 2 of them. You shade both so you can recognize them. Our bases here are these 2 circles. So we shade the base, and we recognize the base is a circle. So the area of that base, I use a capital B there, equals pi r squared. So we circle, plug, chug. It's going to be pi. We trace the radius, 4 squared. That's going to be 16 pi is our base, and that's going to be units squared. Now we write out our volume equation, which is area of the base times the height, and height is the distance between the bases. Now we circle, plug, chug. Base, 16 pi. Height, circle height, 12. We're doing 12 times 16. 192. Some of you are freaked out the fact that I did that by hand, so I'll do it on the calculator. See, now I'm not wrong. That's going to be 12 times 16, 192. So our total answer here is 192. We're doing this in pi form, so I'm going to write pi units cubed. All right. This page, I really want you to take a stab at this on your own. So I'm going to set the timer for 5 minutes. I want you to go as far as you can, as much as you can in 5 minutes, completely on your own. You have 5 minutes. We'll come back in 5 minutes. Go as far as you can. Ready? Go. Okay, let's see how far you got. Okay, so we shade and trace the bases. So the bases here are going to be the two circles. We shade them, those are your bases. Now we're going to find the area of the base. And the area of a circle base is pi r squared. Always write the equation of the base you're trying to find. And this is going to be pi. We trace our radius. We physically trace it. We don't trust our eyeballs here. It's 11, not 22. That's 11 squared. 11 times 11 is 121 pi. And then it's inches squared, and that is our base. Now to find the ball volume, it's base times height, and height is distance between the bases. So our base here is not 22, it's an area of the base, which we have is 121 pi times our height, which is 10. So we simply do 10 times 121. So we're adding a 0 there, and now it's inches, and it's cubed because it's volume. That was the volume of the cylinder there. Now this one's a little bit more complicated. You start by shading the bases, and our bases here were the two trapezoids. So there's one base. There is the other base. Okay, so we shade the bases. Check. Now we find the area of the base. You write your equation. Base area of a trapezoid is going to be equaling the average of the segment bases times the height of the trapezoid. So you write your equation out. And this seems tricky because I'm saying the word base more than once here, but capital B means area of, and those lowercase capitals are segment lengths. So we trace it. One base of that trapezoid is going to be 18. The other base of the trapezoid, we trace it, that's 15. Over 2 times the height of the trapezoid is 10. Okay, so we're doing averaging 15 and 18. We times it by the height, and that got our base area. So the entire base area is 165 units squared. Now volume is going to be area of the base. Notice I'm using a capital B times height, which in this case is the distance between the bases. So my volume here is 165, that's my base right there, times my height, which is the distance between the bases. In this case, it's 24. So you have 165 times 24, we get 3,960. And that's going to be units. Volume is 3D, so that is cubed. What I recommend is you go back, and if you got either of these wrong, fix them and then write yourself a 3-bullet explanation. How do you do this correctly?